Hello, fellow algebra students. It has come to my attention that you guys are not liking algebra, and as your resident nerd, I have taken it upon myself to teach you algebra. So together, we're going to put the fun into algebra. There is no fun in algebra. So here are all the things that you supposedly have to know for the exam. You got simplify, solve, factor, and graph. So it's kind of like your algebra table. You got your four little legs there. But guess what? Stools are a thing. Nobody likes graphing. Yeah, sorry. So here's the thing with graphing. It's not really quite like the others because graphing is just like a representation of all the different things that you can do with algebra. These are just ways that you actually have to change the way it looks. So I'm not going to teach you graphing right now because there's realistically probably going to be 2 or 3 graphs on the test. I think you'll be fine. That being said, we got a lot of work to do, so let's get started. So let's establish the difference between simplifying and solving. They're kind of like the same thing, but there's some differences. Namely that simplifying, you're just making it simpler. You're just going to take it and make it as simple as it can be. You're working with expressions. There's no equal sign. You're not really solving for anything. Which, obviously, because solving is solving. Solving, you're looking for that x. That's what you want. You want the x, and you got the equal sign that you're looking for, the equals. That makes sense? And then for simplifying versus factoring, they're the same thing. They're both expressions, but you're just kind of doing the opposite. So you got the factored form going to the simplified form, so you're doing the foiling, and then here you got the factoring thing where you do the whatever. Yeah, I'll get to it later. But again, before we really get into this, I want to make sure that you know your basic algebra skills, like the stuff that you learn, first semester, maybe early 8th grade, stuff like that. You got your opposite operations for when you're doing your algebra to solve for x, everything. You got the distributive property, 2x and 2 times 4, you should know this stuff, right? You got your solution, you got your no solution, also written like this, just by the way. And then you got your undefined, that's going to be important later. And you see I got these little sheet things here. I'm going to call these pause problems. Pause for 4 seconds, do these, I'll give you the answer, go. Okay, welcome back, and hopefully you should get these light work pretty easy. You got x equals negative 1 and x equals 7. If you didn't get those, I would recommend that you get your basic algebra skills down because it's going to get much harder from here. So let's get started on simplifying. This is our first little section here. There's 4 different key ones that I think you really should know. That's foiling, exponents, radical, and rational. They sound kind of the same, but they're different. You got your square root one and the one that has the x in the denominator. So let's just get started. So foiling. This is basically our, basic distributive property kind of thing. It's reverse factoring. You take these 2 binomials, turn it into a trinomial. You got the first, outside, inside, last. Pretty self-explanatory, so I'll show you what we're doing here. We got the first. So the first 2 of each one, you got the 2x squared. Outside, so both of these, you got the minus x. So these plus 8x, and then minus 4. But that's still not quite a trinomial. You gotta do the good old gathering like terms. So you got the 2x squared. You can add these together, which would give you plus 7x minus 4. This would be your final foiled answer. Now, this isn't inherently super hard, but it can get harder, so I just want to make sure you know how to do this too. Alright, now let's hop into exponents and their exponent rules. I know, you have to memorize them. It's kind of hard, it's kind of tricky, but you've learned them before. It's when you multiply it like this, you get to add them. If you're dividing, you get to subtract them. And then if you have a negative exponent, you get to flip it over. You get the 1 on top. You just got to remember the base has to be the same. Otherwise, it doesn't work. Same with it has to be multiplying or dividing. You can't add, if this perchance was a plus, it doesn't work like that. It would be a lot different. You just got to remember that exponents are weird. They're crazy. When you put something to a big exponent, it gets much, much bigger than when you multiply. And you also got to remember, no negative exponents usually in a simplified answer, which is why you would want to do this. So if you have something like this here, you can go ahead and just add these, which will give you x to the 9th. And then you can subtract these, which would give you x to the 6th. The 4 can stay. 4 isn't really part of it because, it's all part of multiplication. So you get 4x to the 6th. Okie dokie, let's move on to radicals. Everybody's favorite, the spooky, scary square root. Ooh, that's some tongue twister right there. So, for this one, all you gotta do is remember that the squared and the square root are opposites, and so what you're trying to find is something squared, so you can do the opposite, which is square root. So, these are your perfect squares. You have to know these. Just memorize these. It's not that long of a list. I went up to 15. That's about how many I know. couldn't tell you what 16 squared is actually, so memorize the first 15, at least for the test. You can cram, it's okay. Anyway, you're looking for the factors, so in 32 that'll be 16. 16 times 2. You can square root the 16, but not the 2, so you would take 4 root 2. This is multiplication, so 4 times the square root of 2. That would be your answer for that one. When you add in a variable here, if it's already squared, you can just do the opposite, like the square root of x squared is just x. So you pull out this x, and you do the same thing here. This is 25 times 2, so you get 5x root 2. You would pull that x. You see what I did there? Now, if you have something like this, it's the same thing. You know, you're going to have a 5 on the outside of the root. But all this x to the third is saying is that there's 3 x's. And so I like to think of it like this. You're taking out pairs. You're taking out pairs of x's, so you have one pair, and so one of them will go out to the outside, and the other one will stay in there. So you got 5x times square root of 2x. So, yeah, it can get a little confusing, but I'll give you some problems with this. Just make sure you know your perfect squares, and you know how to do the factoring thing, like seeing the 16 and 32. Should be fine, not terribly difficult, I wouldn't say. I don't know. Alright, and here I got a couple more problems for you. Sorry, it's kind of a long lesson, but alas, we have to do it. So, this is all multiplication here. So you got the negative 5 times the square root of 6 times 4 times square root of 6. When you have two square roots that are the same and you're multiplying against each other, it's always just going to be the number without the square root. So you could do, you can do the square root of 6 times 6 equals 36, square root of 36 equals 6, but that's just kind of a lot of work. All just to say that this would be 6. So negative 5 times 4 times 6, I believe, is negative 120. Yeah, I think that's right. And then for this one down here, it's kind of big, kind of scary, I know, but you just got to remember that you can always go like this, and that's a little less scary. So you got to do the same variable rules. Take the square root of 4, so you get a 2, pull out one of the y's, and the x can stay in there, over. One of the x's can come out, and then you get square root of 3. And that would be your answer for that one. Not much more you can do to simplify because there's no canceling that you can do there. So just remember, if you know your perfect squares, if you know how to factor, it should be okay. And like the 6 thing, you can always do things like manually by hand. You don't need to know all the little tips and tricks. Just make sure you know your basic math rules. Alright, and finally, this is the last simplification lesson. This would be rational expressions. If you're getting confused between rational and radical, kind of sounds similar. Just remember that ratio in rational just means like having a fraction, so 1 over x, which is kind of this whole thing. The x is in the denominator, which makes it weird. You got to remember about the dividing by 0 is undefined. That's kind of the big thing for this one. And then you got to play with all your fraction rules. You know how you love fraction rules. So you got to remember too that adding and multiplying aren't the same thing, and solving and simplifying aren't the same thing either. There's a lot of things to remember with this one, but I'm just going to start with the simplifying. This one's multiplication, this one's adding, otherwise they're the same, but you're going to see how they turn out differently. For multiplying, simplifying, I know it's kind of fun to say, but you got to just remember you're going for cross canceling. So for this one, you're just trying to get rid of as much as you can. This 5 and the 5y can cancel, so this would be a 1, and this would just be a y. For this one, I know I'm going to get ahead of myself here, but I would assume that you know how to use GCF. This is 6x plus 2. And then you can cancel this 6, leaving just 1 over x times x plus 2 over y. And then you can multiply this out. This would give you x plus 2 over xy. So that would be how you multiply them. And then for adding, it's a little different. You just want that common denominator. That's what you're really going for. So you're looking for something that would be easy to get them in common. I'm going to go for, like, if you just multiply them against each other, that's usually the best way to do it. So if you just go like this times this, that would be your common denominator. So that would give you 30xy is what you're looking for on the bottom. So to get that, you need to do 5y. Don't forget the top as well. And 6x. So that would give you 25y plus 6x times 6x plus 12 which, of course, you can do all that. You can distribute that out and add, which I'm not going to do that right now. It's going to take a while, and we're already getting along into this video. But feel free to pause and figure that one out. I don't know if it's going to be a very clean answer. Just a random example. All right, next. All right, and finally, I think we're pretty much done simplifying. I did miss a couple things. The one that I caught that I missed is that when you pull things out of here, you're multiplying with whatever's already on the outside. Just remember that. And I know I missed this too. If this is ever division, then you would just do the reciprocal, which means flip it upside down, so 2p over 6, if that was division, which it's not. But just wanted to put that out there. Here are your pause problems. I'll give you 3, 2, 1. And there are your answers to that. If these are looking a little familiar, it's because I got them from the study guide that we were all given. Pretty sure I got all those right, because I didn't actually have an answer key for those. But yeah, just take a look at these. Should be pretty good. Then we can move on. Okie dokie, and finally we get to factoring. Factoring is the opposite of simplifying. I think I mentioned this when we were doing the FOIL lesson. There are a couple different ways to factor, but just in general, it's taking something that you already have and breaking it up into its parts that it's multiplied to. So GCF is a good example. GCF is pretty straightforward. If you see everything in something has a certain number that like can be divided by, in this case it would be 6, then you can just pull it out, and that would be your GCF. You can do this with variables too. So if you had like 2x plus 4x, 2x squared even, you can pull the x out of there, and that would be times 2x plus 4. So that'll be your quick GCF lesson there. I don't think I really needed to do anything else with that. So then that leaves factoring polynomials, everyone's favorite. I'm going to leave a little more time for this one because it's kind of tricky. Okay, and now we can finally talk about polynomials, which in the context of factoring, it's a lot more, but we're just going to start by what is polynomial. You got your mono, bi, tri, polynomial. This would be 1, 2, 3, 4 plus. 4 plus what? That would be terms. So if you have like a x squared plus x plus 1, that's like the very most basic example. But there are 3 different things that are being separated by these addition or subtraction. So that would be a trinomial. Yeah, you following? You just got to know your little root words there, but that's not really the most important part. That's just kind of what it is. So in the context of factoring, there's a bunch of different things you can do, but typically we're doing factoring with trinomials, because when you're factoring binomials, it has to be GCF. So when you're factoring trinomials, it's most likely going to be a quadratic, which just means that there's going to be 3 different ones. That's your ax squared plus bx plus c. So when I have these up here, I have trinomials without a and trinomials with a. That just means, is there like a number there, or is it just 1? Because if it's just 1, then it's not there. So first we're going to talk about the trinomials without an a, because that's nice and easy. And then we're going to go to the ones with. But for now, let me just move this over here. So x squared plus 5x plus 6. All you're going to do is you're going to take this back thing here, and you're going to find its factors. Let me find a different color for that. Find its factors, you get 6 times 1 and 2 times 3. All you want it to do is add to get the middle one. So you can kind of see 2 plus 3 is 5. So those will be your factors. And remember, you're trying to get it to a binomial. So x plus 2, x plus 3. That would be your final answer if you're factoring those. So that's not terribly hard, I wouldn't say. There's some stuff that you need to remember with signs here. So let's see. If I changed this to be, let's see. If I change this to be minus x, then that changes a lot of things. Now you have to think about, and I know how we hate thinking. You have to think about where the plus and minus is going to go. So just as a rule of thumb, if this is a minus, then only one of them has to be a minus. if that makes sense. Because if it was a plus, that means it could be either plus plus, so plus a positive times a positive gives you a positive, or negative times a negative gives you also a positive. But since this one is negative, that means it's going to be plus and minus. Let me write that a little better here. So it's the same thing. You're finding the factors of this back one, which would be 6 times 1 once again, and 2 times 3. But now you have to think about, they have to add to get a negative 1x. So you have to get the 3 has to be the negative, and the 2 has to be the positive, if that makes sense to you. I'm kind of going quick here, so, just if you need to pause or think about it a little bit. That would be your final answer for that. If this one was a plus, that just means that they're both negative. So I don't know if this is correct anymore, but that just means they're both negative. It's the x minus x minus. And that would be all you need to know for that. Now, let's get into good old with an A term. Oh, and you can see that now. That's okay. With an A term, it gets a whole lot harder. Now you have to think about a whole different thing. So now you got the 3x squared, 26x plus 35. Looks like a Y. I'm sorry, I switched colors again. Now, you have to think about the factors of this one, which would be 3 times 1. There's only 1 for that one. And then you have to think about the factors of this one. So 35 times 1 and 7 times 5 would be the factors. So for this, now you have to think about multiplying across and then adding to get the middle. So, well, just to start with, in this case, the number is 26, and 35 is already too big, so it's not going to be this one. So what you want to do is multiply across and then add for the middle. So I'm looking at this here would be 21. 3 times 7 is 21. This one here is 5. So 21 plus 5 equals 26. That's what we're looking for. So now we got to do the whole big challenge of fitting it into here, which in this case they're both pluses, so you don't have to think about the plus and minus thing. But you do have to think about where to put them. So these two are always going to be in the back. This is considered a back spot here. So we can just put those in right now because it doesn't really matter. If there were different signs there, it might matter, but since it's just plus, you can put the 7 and the 5. You just got to make sure that the one that you're multiplying it to, so 3 times 7, has to be in the opposite binomial. So the 3 times the 7 is here, so the 3 has to be in the opposite one, the 3 has to be here. And then that just leaves us 1 left. So 1x, or just x, because it's the same thing. So that would be your answer for this one. It does take a little more work, especially if there is different signs and everything. But I think it's not quite as hard as people think. You just got to know how to do all this. And you can write it down, too. You don't need to do it in your head, even. That would be your trinomial with an A term. And then I'm going to talk a little bit about perfect square trinomials, which is not so much a different thing as just a faster thing. Perfect square trinomial like this one, so x squared plus 6x plus 9. This is one where if you kind of know what they look like, it's much easier because you can see if you take the square root of both and then it doubles to get this one, if you're following, then that would be a perfect square trinomial. So this would be x plus 3 squared. So that's a little easier to see when you're going the other way, when you're actually simplifying it. So if you look at this and you say, well, it's the same thing as just doing both of the same thing. You multiply this by this, which would give you your x squared. This would give you your 9. And then the 3x plus the 3x will give you the 6x. So that one's just something that's good to know, the perfect square trinomial, because later we'll get into completing the square, and completing the square really does not make sense unless you know how to do this. So that's all for factoring polynomials. Hopefully that made sense. And here are your pause problems. Give you a second for those. And there are your answers. So that's probably all for factoring. Factoring, I mean, it just takes practice. You got to think about it a little bit. But now I got a whole thing about solving to do, so let's move on to that. And here we are with solving. There's just basic straightforward solving, like just your normal algebra solving for x kind of thing. I'm not going to talk about that very long because I include that in my basic algebra part. Inequalities, I bet you forgot about inequalities because that was a long time ago, and I think our teachers did too, because looking at this study guide, I don't see any inequalities on here, but I'm going to review those anyway. Functions, just in general, linear, quadratic, that kind of thing. The rational ones was what we were doing before, and then quadratic, like overall, completing the square. Anyone completing squares? Yeah, we had a hard time with quadratic, so I'm going to also highlight that part. Alright, let's jump straight into some inequalities. So, like, the basis for solving is that you're finding the x equals, but you can also do, like, x is less than, x is greater than. You should know all these by now, like, you shouldn't be surprised as to what these are, but the trick I always learned, and I still remember, is the little monster always likes to eat the bigger number, so, 2 is less than 5. Anyway, that's just my little thing there. So let's start with an example. Plus 5 is greater than 7. I'm not gonna do like a whole bunch of these, but just the trick is you gotta remember that when you're doing these, if you end up with dividing by a negative, like this -2 here, that you just flip the sign. So that would be a less than now. So x is less than -1. So that's your big trick that you have to remember. And also, I know I said we're not going to do graphing, but if we're going to do like a number line for this one, you would get 0 and then -1. X is less than -1. You put a circle there because it can't be equal to, and then it would just go that way. And there's stuff for graphing too, but that's your inequalities. Let's move on. And let's also real quick talk about functions. Functions I categorize with solving because it's like a y equals. It just shows like a relation between two things. So the input output dependent independent for like the x and y. That would be your function things. There's a whole bunch of rules about functions and stuff, but just in general it's like the y equals and then you get an output from that. So the two that we mostly have been working with are the linear and quadratic functions. Linear makes a line and quadratic makes a parabola, which I know I said we wouldn't really do much graphing, but that would just be something along the lines of that. Yep. So, I also, sometimes it's a little hard to remember what quadratic really means, and I always like to think of it as, you got your first degree is like one dimension, is like a line. Second degree is when you have a squared, it's square. And what does a square have? It has 4 sides. What does quad mean? 4. So that's probably where that word came from. Quad as in square, and square as in second degree. So that's just something I like to think about. And then also just remember that direct variation is also a thing. It's a type of linear function that just means that there's no plus b. It's just always, there's a constant, the constant k, and that's the whole thing. That's essentially it for functions. Alright, now we're going to talk about the rational equations, which is not going to take as long as probably the expressions because that was a lot more. So basically for this, you just want the denominators gone. You just want to get rid of them in any way possible. So you want to find a number that you can multiply the whole thing by that will just get rid of all of them entirely. So in this case, to get rid of a 14, you could have like a 14 and then divide the 2 and the 7, so that would work. And then you need an x squared. That would be your biggest thing there. So sometimes people think it's the 14x squared. Sometimes people think that you have to multiply them all together, and then whatever that huge number is, that's what you have to multiply by. But you just have to think about it individually, because these are all separate terms. So just as long as everything will cancel out in each term individually, then you should be fine. And you just want the denominators gone. There's no like terms or anything, or common denominators, I mean. So you multiply all of this by this. The trick for these is you take the thing that you're multiplying by, which is 14x squared. So 14x squared divided by 2x, so 14x squared divided by 2x, whatever that is. This would be 7x, right? Yeah, 7x. Then you multiply the 7x, by the top number. That's what you're going to do for all of these. So the 7x, or 7 times x plus 9. wait, I was right before. 7x times x plus 2, and then plus this one, 14x squared, it was x times x squared equals, so you take this, divide by x squared, 2. Yeah, so 2 times 4, that would be 8. If that makes sense. I might have gone a little fast, but you can pause and think about it if you need to. And then all of this, so this would be 7x squared plus 14 plus x squared equals 8. I didn't actually check if this was going to make a clean answer, so if you want to keep going on this, you can, but I'm not going to. Oh, I forgot the squared. You can keep going on that if you'd like, but the idea is you just want the denominators gone, and then you can do all the rest, which I think this one will turn into a quadratic, and I'll talk about solving quadratics next, so let's move on to there. Alright, now finally we get to the big boy. We get to quadratic equations, which is, this form here, the ax squared plus bx plus c equals 0. So what's all the big hype about it? Well, there's just a million ways to do it. Not a million, there's 4. I mean, plus graphing, but we don't like graphing. Nobody likes graphing. So there's factoring, square rooting, completing square, which a lot of people did really bad on the test about, so I'm going to highlight that. And then there's the quadratic formula, which, by the way, these aren't the same thing. Quadratic equation, quadratic formula. Quadratic equation is this. The formula is the whole thing that you use to solve it, which we'll talk about next. But first, let's just quick review what makes these kind of special, these quadratic equations, and this is our form that we're used to. So when we look at it on a graph, there can be 2 solutions. That's kind of the big thing, because you're looking when y equals 0, whatever crosses this line is the solution. So in the same way, you could also have just one solution if the bottom of it, if the vertex is right here on the line, that would be one solution. Or you could have none if it's just like way out here, if this was your graph. So that makes it a lot more complicated. It's not just x equals one thing. And also just the fact that there's a squared in here, that means that inherently there's going to have to be some square rooting, there's going to be some more complicated things. So it's a big thing to get into. So let's start with the square root method of solving. I'm going to start with this one just because it's pretty much the easiest. I mean, there's not a lot to really think about other than you want to make sure that you get your x squared equal to some kind of perfect square. So remember your perfect square list from before? I hope you do, because that is what we're doing now. So, you just apply the same operation to both sides. You do the square root of x, and then the square root of 64 is 8. But you also have to remember, because it's quadratic, there can be 2 answers, and because it's square rooting, when you square root things, it can be a positive or negative, because negative 8 times negative 8 is also 64. So just anytime you do that, remember to add the good old plus minus 8. So 8 and negative 8 will be your answers for that one. So the idea is you just want to get it into this form where there's x squared equals a perfect square on the other side. So for this one, if you were to factor a 2 out of all of this, so you divide everything by 2, and then you get x squared minus 1 equals 15, and then plus 1, x squared equals 16, square root both sides, x equals plus or minus 4. So that's the kind of thing you're looking for square roots. This doesn't happen very often. It's never really that easy, but if it does, that's great. And moving right along to factoring. I think factoring is probably what you would see the most, just because it's the hardest, and math teachers are the worst. So sorry if you're watching this, math teachers. Yeah, so you're gonna see a lot of these. We talked about this one. I think I even used the same example before. It's just factoring trinomials. So there could even be an A term, possibly. So what you're going to do is you're just going to do this whole factoring thing. Let me grab my red here. Sorry. You would do the x plus 2 and then x plus 3. Still equals 0. All you're doing is rewriting it in a different way. Except now you have this. How are you getting an answer is kind of the question. So the rule you just have to remember is opposite opposite. That's what I've been told. So you take the opposite sign of this one. So a negative 2, and then divide it by whatever's here. Since there is no a term, there's nothing there. So it's negative 2 over 1, which is just equal to negative 2. So I'll explain this a little more, just to make it a little clear for you, because sometimes it doesn't make sense to people. Is like if you had, whatever, 3x minus 4, the reason you would do opposite is because if you actually go through and do the algebra and you want it to equal 0, you could say 3x minus 4 equals 0. So you add 4, so plus 4, that's your opposite sign of this one. And then you have 3x equals 4, and then you divide by this one. So x equals 4/3. That's why you would do that. So anyway, all of that to say, you do your little opposite thing, which would give you x could be equal to -2 or -3. And there are your two answers, because it's quadratic. And of course, there's always scenarios where it could be just one answer or even none, but usually for factoring, you're going to get these two from the binomials. Alright, here we are. This is completing the square. This one is kind of rough. I'm going to spend a little more time on it. I know we had a test on this recently and people did less than great. What they're going to give you is something like this, where you have the ax plus bx, and then if you know the rest of it, you would know that this is plus c. But they're not going to give that to you. And the reason you would want to do this is you're trying to get to this perfect square trinomial, which is what I showed you before, if you would remember. You want to get to this so that you can square root both sides, and then it's just that much easier. Instead of, compared to the quadratic formula, which kind of takes a long time, it's a lot of just writing things out, this can be easier. But it doesn't make a lot of sense if you don't know, if you don't understand why we're doing it. So I know some teachers taught this and some didn't. The reason it's called completing the square is because if you apply it to geometry, there's a literal square that's missing. When they just give you this part, like if we don't have the c, there's a part of the square missing. So you're completing the square by finding this final part, and this is how you find it. So I'm not going to prove that that's why that's the equation. That's just what it is. So if you want to trust me on that, otherwise you can go look it up yourself and verify. That's what you're going to be using. So basically, if we take this as an example, you take the b term, which is 6 in this case, and then divide it by 2. There's no a term, so it's just 6 over 2 is 3, and then square it is 9. So this is your c term. That will be what you're looking for. So your final answer, on one side of it, the plus or the equal 0, should be something else. But this part of it should be binomial, like a binomial squared. So let me write myself a new one here. If I did x squared plus 12x equals 0, and you did 12 and half squared, so half of 12 is 6. 6 squared is 36. So you would add 36 to both sides. Don't forget the other side. Get x squared plus 12x plus 36 equals 36. And then you could just turn this into a x plus 6 equals 36. Oh, squared, sorry. You take the square root of both sides, and then you would get x plus 6 equals 6. And then x equals 0. Which, because I just picked such an easy example in this case, x would equal 0. But a lot of times what they'll do is there's going to be something else there. That just makes it a little harder. I did that because I knew it was going to be a perfect square. But yeah, and it's not always going to be in this form here. Sometimes they'll leave it in the normal form. So if I my green, they'll have a plus something. But what they'll want you to do, because I don't know, math teachers, I don't know. What they'll want you to do is do that so that you just have a c over here, negative c, and then you still complete the square. So if it's already a trinomial and they ask you to complete the square, that's what they're looking for. The whole concept is kind of weird for a lot of people, so I'll give you some practice problems when I get to that. But I don't know, just you got to think about the literal square and you got to think about the perfect square trinomials, or the square binomials. So hopefully that makes sense to you. And finally, for this solving quadratic equations part, we got the quadratic formula, which is just so cool. It's so awesome because you can just use it anytime. On the test, they're going to tell you, oh, complete the square. But you can just use this anytime, like especially in the real world. You can just plug it straight in there and it'll always work. I mean, there are cases where if you get a negative number in here, then that would be imaginary. So that's not what you really want, especially in Algebra 1. But I don't know. I feel bad for whatever little mathematician made this up, and then math teachers were still like, no using the formula. Anyway, that's just me loving the quadratic formula. So I'm not even going to do any examples of this, because it really is just plug and chug, as they say. You put in all the letters from, ax squared plus bx plus c equals 0. Just make sure it equals 0 first, by the way. But you just plug in all the letters and then figure it out. There's going to be 2 answers because of this little plus and minus here. The other neat thing is this whole portion here is called the discriminant, and it'll tell you exactly how many answers there are going to be, which you wouldn't really need to do that if you're just solving it normally, but sometimes they'll ask, just like using the discriminant, how many answers will there be? That just means you plug in these parts, and then if your answer is positive, then there's 2. If the answer is negative, then there's none. And if the answer is 0, then there's 1. So that's just your little hint there. The reason that is because if this is like a square root of negative 12 or something, then that's no solution. And if this is square root of 36, then you get plus and minus 6. If this was square root of 0, that's just 0, and that's one solution. So that's all for that. I mean, I'm not going to do a whole bunch of examples, but pretty neat. Alright, so here are your pause problems for this one. So first I'm going to show you these. These are from ChatGPT, by the way, just the problems. I'm not anti-AI. I mean, some people think I am. These, I'm going to give you the problems, and then in the next clip I will be giving you what kind of method you should be using. So I want you to guess what kind of method first, and then I will give you the method, and then you'll solve them. And here those are. So factor, complete the square. And then this one, just use the quadratic formula. This one, use the quadratic formula, but check the discriminant first because there is no solution. But I just want you to go ahead and plug that in and tell me why. Tell me why there's no solution. And here are your answers. Sorry if you can't see this. This says no real solution for this one. That just means square root of negative would be imaginary. For the rest of these, like for this one, I wouldn't simplify it out unless you have a calculator on the test. Pretty straightforward, and that's pretty much it. Yeah. I think if you know how to do all these just by yourself and you can figure out which method to use too, you'll probably be good on quadratic equations. And that's pretty much it. I've taught you all I really could right now. And when I say teach, it's more a review. I'm not really teaching that much anyway. I'm sure I missed a whole bunch, so please just let me know if there's anything that you're still confused on before the exam, probably. Or if you'd want, I mean, I know the school year is almost over, but if you want me to make more videos of this sort, I would be happy to. I have nothing but time this summer. That's false. I have stuff to do, but I'll still do it. And, maybe if you're just like hallucinating enough, you can actually find the fun in algebra. That was so stupid. So yeah.